So I'm going to talk about Graal, and we have Graal Enterprise, right? And who we usually talk to about Graal is people are spending a lot of money on infrastructure. Um, People who, oops, there we go. They're doing cloud-native apps, microservices, serverless kinds of use cases, where you have a lot of small and medium-sized instances of the program to run across the cloud. And I think anyone to look for to improve reliability. So unfortunately, to date, the best way to fix computing issues is still to turn it off and on again. And for that to be effective, you want instant startup, right? So fast startup for Java really helps reliability in a lot of scenarios where you don't have to keep things warmed up. And then I think in terms of developer productivity, the ability to reuse languages, libraries from any language that you want, mixing Node libraries or Python libraries, in your Java programs and vice versa, without any extra overhead to add those additional languages, that's something we also see as being important. So what's in it? There's the compiler that either compiles just in time or ahead of time. We have two runtimes. We have a fork of Hotspot that we recommend for larger apps, and Substrate VM for like cloud and embeddable apps. And actually, people sometimes ask me about that. The original use case for Substrate VM was really to run a JVM in the database, so that basically all the things that Java wanted to control, that the database also wanted to control, we could virtualize them. So resource management or memory management and I/O kinds of things that the database wanted to control, we could let the JVM relax a little bit and not have to control everything like the way Hotspot wants to. We have a language implementation framework we call codenamed Truffle that makes it very easy to add new languages. And we have many use cases of people doing that. It's pretty hardcore, but it's cool. In terms of languages we directly support, we test with Java and Scala, as far as JVM languages, and JavaScript, of course, those are all production. Python, Ruby, and R right now we call them experimental. I would say Ruby probably is in the best shape right now. Like, we may be able to declare it production by the end of the year. Python probably another year away, I think, before it's really production. And R is like, kind of an interesting niche. We'll talk about that. Then we have tools. We do a lot of work to integrate Graal with our tooling suite. So we've done integrations with debuggers like Chrome and Visual Studio Code. We have Visual VM, which is a standalone tool for optimizing a lot of things. And so we have tools that go with GraalVM. And it's definitely the case that GraalVM, not just because it's mostly developed in Switzerland, is a Swiss Army knife of programming toolkits. And most people find that they only need a subset, right? So, for example, if you think about the way Quarkus, Red Hat Quarkus uses GraalVM, they use the compiler for AOT and Substrate VM, but they don't care about other languages. NetSuite is using GraalVM as a way to run customer code that uploads into their single large Java instance. They run it in our sandbox, and they use JavaScript. The database, Oracle database, will be supporting in production JavaScript later this year. That's Oracle Database 21C, and that uses Substrate VM as well. And then you may have seen, some Twitter comments on Twitter about their use of GraalVM, and they use it the compiler in JIT mode. They don't use Substrate VM. And our goal is really to try to be language agnostic. So I know I'm talking to the Java users group, but from the Graal point of view, we don't want to necessarily be too Java centric. Our goal is to support languages, and as you can see, actually, most people are not using any one language. There's a wide variety of languages out there. Others is the biggest one by far, and I think there's a lot more opportunities to do new, interesting things, innovating at the language level that Graal is going to enable. We have two versions. We have a community version and an enterprise version. Actually, both of them are free for developers, basically. And then we have, like I said, two modes: the JIT mode, where you run Java programs, kind of the way you're used to with OpenJDK, or you can run ahead of time compiled, where you build the class into an executable, like a native C++ program, and then just run the executable. So it bundles everything you need to run your program as a part of a single binary. And of course, now we support most of those other languages that I mentioned. Right now, strictly in JIT mode, we don't yet do ahead of time compilation for Python or JavaScript. Although we do have a project to do that, and hopefully that may be something you'll see more of next year. So one of the things that's cool about working for a large company like Oracle is we have lots of internal customers who you can arm twist to trying out and being guinea pigs. And so we've got a lot of them, and that's really exciting that they're making commitments to use GraalVM. And in particular, NetSuite is as I said, a big user. They care about the embeddability and security for Suite script, and they cared about the efficient Java to JavaScript interop. And support for the latest version of JavaScript. It's a language that moves very fast. The database folks wanted to support popular languages beyond PL SQL. If you're an Oracle database person, or you're kind of used to these database programming languages, they're a little quirky, I'll just say. And they wanted to allow people to run basically the stuff you're used to doing when you're a JavaScript programmer. Download stuff from NPM and just run it in the database embedded. And they don't need fast interop between the native code and the managed language code. And so JavaScript's our first language there. And then Oracle Cloud Infrastructure, they're running GraalVM as the standard way they run Java throughout Oracle Cloud. And they were just looking for the fastest, most efficient way to run Java. And they did a great blog post for us last fall. And that was on an much earlier version of Graal, but they saw some pretty good metric improvements. And this is from their telemetry service, which is their largest service in terms of number of cores. And if you Google for GraalVM powers Oracle Cloud Infrastructure, you'll see that see a lot more detail on this benchmark. And it's something that we're putting into kind of our whole application stack as the runtime for basically people that want to run a program on a computer. And one of the things we've been doing a lot, maybe I threw these slides together at the last minute, so I apologize if I have to jump around. This is a little out of order from how I usually do it. We've been adding a lot of platforms support over the last year since we released Graal. And so in particular, we added JDK 11 support this year. We added Windows support. ARM64 came out for Community Edition this year in the spring. That's going to go supported in production for our enterprise customers at the end of this year. And coming soon, we'll have some more Linux variants and JDK 15 as well. And so there's a new release every quarter. This is our release roadmap. It's fairly complicated, but basically what it means is every quarter there's a release. There's a Community Edition release and an Enterprise Edition release. We have critical patch updates with all the security fixes and whatever that we do every quarter, and that's kind of where we align our releases around it. And it's just kind of described. You can find this on our website. Which version of OpenJDK we pick up, and we have the database style release model where it's actually kind of not that dissimilar from the way Java works, where there's a long-term release every 3 years. So that's going to be Graal 20 at the end of this year. We'll kind of have that be the one that has a long term of support, and then the Community Edition releases stop after a year, and that's what's going on there. So Oracle, as I mentioned before, GraalVM Enterprise is big at Oracle, but why? So performance, startup, footprint, and embeddability. That's kind of our big set of claims to fame. So in terms of performance, these are the benchmarks we ran last year, which is we have this benchmark suite we have called Renaissance that we use. It has more modern features of Java in it. It uses like streams and lambdas that were introduced in Java 8. Some people call Java 8 modern. And people that are writing benchmarks, that's actually fairly modern. Those features aren't actually widely in use, but it's actually a fairly old version of Java now. It's 6 years old. But we updated the benchmarks, and this is just kind of our best guess of across a wide variety of modern Java what you're likely to get. And that number went up a lot this year. So now we're up to like 50% faster than OpenJDK across a wide variety of benchmarks. Now, obviously, your mileage will vary. Some of these benchmarks you get like a couple percent, 10%, and it all depends on what you're doing. And so we're continuing to make progress on this. I'd say about overall, maybe about 10%, better than where we were last year is kind of our current state of the world for Java benchmarks and of course, the thing I think that gets us the most excitement on the internet is the startup time for cloud frameworks. There are a number of frameworks I think out there right now that I call them, really cloud enabled. Micronaut, Quarkus, and Helidon, and they start up in tens of milliseconds rather than a second or two with GraalVM as an ahead of time compiler, and that's just huge for cloud applications where you're starting and stopping them a lot. And then, of course, the other thing that sometimes people forget about is that there's actually a big memory footprint reduction when you use ahead-of-time compilation, because you don't need to keep around all the apparatus of the just-in-time compiler, and you don't have to keep around bytecode as well as the machine code. You just have to keep the bytecode, just the machine code around, and a lot of mechanism that you need to run a traditional Java runtime that you don't need when you want to specialize it for one specific application, and that means it can fit into a smaller memory footprint. And then coming up strong now is Spring. And so we've been working very actively with the Spring guys. This is a snapshot of Sebastian Deleuze, who's the lead on Spring Native, which is the GraalVM Spring project. And so I think most people that we run into in the Java world are using Spring. They have people that are colleagues that are using Spring. And so being able to deliver that, which is very complex, wide-ranging, a set of libraries on GraalVM Native is super exciting. I think they're at like Spring Native 0.8 now, and we're closing in on it where they'll I think be able to certify a 1.0 release that they support, at the end of this year. And lots and lots of stuff is working on the Spring ecosystem right now, so that's super exciting. So when you have low footprint for memory and instant startup, it improves many things, right? Like in the cloud, you often have to keep around a container just in case some work shows up. From the security point of view, you can use process isolation, and it's not as onerous to build your application infrastructure with lots of processes if each one is small, and you can start them up when you have a new load. Robustness, memory leaks and long-running programs go away when you just restart things a lot. So making restart, not such a pain point, massively helps robustness. And then the other thing that I think is really interesting that people are starting to do more is what we call build time class initialization, right? So you can actually put metadata, like the stuff that you need in every request, you can bake it into the image itself. So things that are in a static initializer, typically in Java, where your program fires up, it runs all these static initializers that load XML configuration files and what have you, and you can decide, hey, I'm going to keep the same configuration, JSON files, YAML files, what have you. I'm going to keep all that stuff constant across a lot of instances in my cloud deployment. Pre-calculate that at build time, and then you have to integrate that with your CI/CD pipeline so that when that metadata changes, then you rebuild images. So if you're willing to rebuild frequently, then there's a lot of neat tricks you can do, and I see that the framework people like Quarkus and Micronaut and so forth are really now trying to tune, get those footprints even smaller by making sure that they can do more metadata calculation and at build time rather than at runtime. So in terms of Graal Enterprise versus Community, that's basically a performance, security and manageability and support kind of thing. Right now, I think that the bigger differential is around performance, where we have just more optimization phases and profile-guided optimizations for native image. We have a cool feature I'll demonstrate the little video in a second around safe execution of native code, JFR events and native image, and then, of course, support from our team. It's a commercial product from Oracle. There's a trade-off between ahead of time and just-in-time compiled, and right now it's still the case that the just-in-time compiled stuff can hit a higher peak performance number than the ahead-of-time compiled stuff, although our ahead-of-time compiled version of Graal EE is as fast as JIT compiled hotspot. And so that was kind of a great milestone, but we're going to get that red line up to the top of the blue line, hopefully in the next 6 to 12 months. A lot of projects to improve that this year. And then I think the best way to kind of think about performance and cost is actually what we call memory adjusted performance, which is requests per megabyte second. In the Java world, if you're willing to throw more DRAM at the Java heap, programs go faster. There's not as much garbage collection, but of course that cost goes up, right? If you want to squish the application into less memory, you can always set the heap size lower, and then it's going to collect garbage more frequently, and your throughput goes down. So requests per megabyte second is something that actually captures that metric, and is also something that corresponds most clearly in the cloud. Like if you want to go use Amazon Lambda or Google Cloud Run or Oracle Functions, where you're doing serverless, you're paying by like basically the megabyte second or gigabyte second. There are little step functions there, but basically your cost when you run your program is proportional to the number of megabyte seconds that your program runs on a core. And so that's the metric where you can see when you combine the startup and footprint stuff together, as well as peak performance. Native image has huge benefits for both community and enterprise versions, and that's why there's just tons of excitement out there about that. Let's see if I can get this thing to run. Yes. So here's a little C program that we wrote. And what it's doing here is it's going to put some garbage in a pointer and dereference it and create a seg fault. But we have a managed version of it that uses the LLVM front end to compile the C into bitcode. But then we interpret the bitcode, and you can actually get an exception that you can catch. It won't corrupt memory. And so for people that are integrating native code into Java code, that kind of thing can be very useful. I'll talk more about this later. This is we have what we call a sandbox to allow the truffle languages to be encapsulated with memory limits, CPU time limits, and so forth, so that you can have different levels effectively of security for your programs, where if part of the program is coming from your customers, you maybe don't trust them as much as you trust yourself to have secure code. You can create limits on how much of your base application is exposed to the customer-provided code, and how much memory and CPU those things can take. Now, this is kind of another way to look at the trade-offs of speed and throughput. The other thing that you get a benefit of right now with the JIT mode is in terms of latency for garbage collection cycles. We have a lot of really advanced garbage collectors in Java. And I think later this year, ZGC is going to go production in the Oracle JDK 15. And that's a very low latency garbage collector. G1 was introduced a little while ago, for those of you that are post Java 8. And those are really nice advantages for JIT mode. And with ahead of time compilation, then today you get speed to start up, low footprint, and then a small package to distribute, which is nice for a lot of the applications as well. Now, the way that JIT works in Graal, and this is not atypical for any JIT compiler, what happens is you run in the interpreter, which is this thing here on the bottom left, and you're going through different parts of the program, which are represented by these little boxes. Then it notices that something's hot. You compile the code like you're going to compile this X function here, and you might compile another function Y. We call here a PE boundary call is partial evaluation. That's partially evaluation. We evaluate part of what the interpreter does and compile just that part. So it's compiling part of your program, not all of it. And then of course there's typically a runtime, which may be some C code, like in the database. That's just the stuff that does transaction processing and basic data management there. So your native code here can be called equally well from the compiled code or from the interpreted code, and you can do something else which we call de-optimization. Now, the way the compilers work in general is that they start off without knowing a lot of information about the type system. And Java has more information, but certainly for JavaScript or most of the other languages, really know nothing about what type of object you're going to get here. And this could be like A equals B times C, maybe the top node equals B times C, which is equals like E plus F or something. And so what happens is as you start seeing the profile of what people are actually using there, you're going to specialize the nodes to figure out what type they actually are in practice. And okay, well, for this particular expression, it seems like these things on the left-hand side are always integers, so I'm going to compile them and assume they're an integer. And then what happens is that assumption you made that they're always integers may turn out to be wrong. So we have a check in there, and you say, oh, okay, now I found that there's a double used in a couple cases. And then we decompile it, we call it de-optimization. We run back in the interpreter again, get a new profile, see, okay, yeah, there's a double there now, and that seems to be a new thing, and we recompile for that. And that's kind of the core of what makes Graal work, and it does this in a generic way that doesn't have to know anything about the language. Now, in ahead of time compilation, some people think of it as, ahead of time compilation. We call it that because that's the popular usage, but it really is actually a version of snapshotting. Because what happens is when you run the build tool, it's running a hotspot. It loads all your libraries and your classes in your application just the way they'd be loaded if you ran in normal JIT mode. But we force the JVM to load everything that we can find, and we iteratively find all those things. And then we iterate, we run initializations of the class initialize we need to run, and we snapshot the heap and we repeat until we get to a fixed point. And then what happens is we write out code that we find in the text section, but equally interesting is we pre-generate images, and we call that the image heap, and that goes in the data section of the native executable. And so the inputs to this whole process are not just your application and the libraries there, but the libraries, from the third-party libraries you might be using, Apache Struts, Hibernate, whatever it is, the JDK itself, and then the libraries in the JDK, that is, and then Substrate VM, which is kind of our VM that's designed for runtime. So in the ahead of time versus JIT compiled mode, what's happening is like in JIT version, you first have to run the JVM itself and load that executable. It has to load classes from the file system. It's going to verify the bytecodes, from the classes it loads. It's going to start at the interpreter. It's going to run static initializers, and it's going to run the first tier compilation. It's going to gather a profile, and it's going to learn their second tier compilation, which could be GraalVM's compiler, or it could be the C2 compiler, which is kind of the standard compiler in Hotspot. And then finally, you get the best machine code. And in AOT, basically, all those steps have been, kind of short-circuited, and you immediately start with the best machine code. And the heap has already been pre-prepared with all the objects you want in startup. And here's just some more data that, if you kind of look at it in detail, this is a startup inserting a couple of requests. And what happens here, like in JIT mode, you can see in the first second, there's a lot of work going on, and it's taking you 5 cores, and its memory is going up to 300 megs. This is what the JIT infrastructure is doing. And then we have a little bit of work here at 6 seconds and at 9 seconds and something. And you can see that there's still like some fat stuff going on here. That means there's more classes that they've identified to compile. It's the heap size keeps going up to 350 megs. And it's taking us, a while to get going here, right? And in the case of ahead of time compilation, not only is that startup phase gone, but the requests, they don't have to do work to continue to find more hot stuff that you didn't find necessarily in the startup phase of your runtime. And so in JIT mode, you kind of get this unpredictable behavior because you're never sure if you compiled all the classes that you really want to compile. But more importantly, you can see you don't need all that memory to do all the compilation at runtime. And then as far as memory footprint goes of JIT mode versus AOT, in JIT mode, you need the executable of the hotspot itself. You need the application's data, whatever data it's processing, the bytecode data, metadata so that you can do reflection, and the code cache that keeps around machine code with compiled bytecodes for whatever has been compiled, the profiling data, which is another set of data that's tracking what's going on, as I showed you, and then, of course, the compiler itself has its own data structures, right? And so all of that stuff is basically what you're getting rid of when you go into AOT mode, other than just basically the application executable, which is kind of the equivalent of the code cache and the JIT size. It's all just machine code, and then the application data structures itself. I think I showed that thing before. Ahead of time, also has something that you can do in C world, right? Which is for C compilers, which is profile guided optimization. So even if you are doing ahead of time compilation, what you can do is you can run the ahead-of-time compilation with an instrumentation framework, run your application with a relevant workload, get a profile that way, but that profile is separate, it's not needed at runtime, and then you generate the program again with PGO, and you get a more optimized binary. And that's one of the key differences that we have in our Enterprise Edition. Now, what we want to do over the long term is we call it eat your cake and have it too, to mitigate the downsides of ahead-of-time compilation, where we think we can improve the peak performance with better PGO. We're adding in the G1 garbage collector. It's currently experimental since 20.0, but that should go production by 20.3. And you want to simplify the runtime deployment kind of stuff with a tracing agent for reflection. So sometimes people don't realize that to use build time initialization, you have to configure things. There's a number of other places where reflection is used. We have to do configuration. We have an agent that watches what a program does in hotspot and generates that configuration so that when you do native image, we know what reflective runtime things you need to do. So that's our kind of goal for release 20, and we'll see if we can hit it there. Maybe go into 21, but I think you have a good chance of getting to the JIT peak performance number and getting the max latency numbers down so that the JIT mode doesn't have any edges over AOT whatsoever. Now, the thing about Graal that I think really starts blowing people's mind is when you start talking about multilingual interop. So here we have a little JavaScript program that's requiring in the module. It's just getting doing some web serving stuff here, and the text that I'm going to do is done in JavaScript, but then I want a big integer, which is a class that Java has that JavaScript doesn't have. So I just say I want a Java class here, and then we're going to stick a big number in it, take 2 to the power of 100 and convert it to a string. And then we want to do our most general purpose mechanism for calling other languages, where I give the name of the language I want, which here is R, and then I run my small little R program. And what happens here is you get the web page that says, prints out the hello world in JavaScript, prints out that big number from Java, and then it uses R, which has some really cool plotting libraries to plot a sine function here. So that's where things kind of really get interesting. Now, embeddability, I mentioned that. You can create multiple VM instances in a single process. So here we have a simple Java program that's creating 2 contexts, and they'll both work and can operate independently. And then I think what's really interesting is that when you're doing this language interop, they're all really being treated like the same language. It's kind of the unification of all the languages put together. And that means that, and the way that works underneath the cover is that you can virtualize any object layout. So a Java object can be virtualized to look like a JavaScript object or vice versa. So when you pass a JavaScript object into Java, and you call a Java method on it, it knows where to go get fields the JavaScript way. It's actually implemented kind of with small talk messaging at the lowest level. So you can create virtual objects. And so here we have a little virtual array we've created. We want to have a really big array. You can see here we want really big numbers in it, but we don't actually want to have memory for it. So we're just going to return that the value of the array when you give it the ask for a particular member with an index. We're just going to return the index times 2. We're not going to let you stick anything in there, and the size of this array is going to be the maximum value of long, which is a very, very large array, right? It's I think 4 billion times 4 billion, so it's that's a very large number. 16 times 10 to the 18th. So I want to go now. Basically, take an array, and I want to add in the value of the first element with the value of the millionth element, and I get back kind of what you expect. So you can see the array evaluation for JavaScript is working as you'd expect, and so you can make virtual objects out of any underlying memory data structure, and that's very useful for us in the database, and that's something we're just really starting to take advantage of in the Graal ecosystem. So as I mentioned, some of the value propositions for running JavaScript or Polyglot in general, why would you want to mix languages together? Isn't that weird? So I think NetSuite, as I mentioned, has the JavaScript embedded in Java example, and we're actually seeing a lot of people want to do that. Goldman Sachs has a really interesting project. They have a language that they wrote for securities risk analysis called Slang, or securities language, and they wrote it in the early 90s before Java came around. And they're actually porting that language onto Truffle and running it on Graal, and then having Java interop with the other languages, which is great. A lot of people that were used to Nashorn and Rhino in the Java ecosystem, find this to be useful. And that's, I think, some place where we're seeing, some traction now. Nashorn is being deprecated in Java 15. So the Nashorn folks are starting to really play seriously in what's going on? Annotation request. Brett B is requesting to annotate the shared content. Do I want to do this? Oh, I see you're on mute, Brett. No. Okay, decline. And here's a server-side React rendering. It's actually a really great use case for Graal's JavaScript where it runs faster than Node. So I think we're starting to find more use cases for higher performance JavaScript with GraalVM. And so running Graal and Node, it kind of plugs in an interesting way. So here's the architecture of when you're running conventional Node, where you have the JavaScript code here in the green, and then the native code in the light brown, with all the native bindings and all the native modules. And there's a V8 API, which is a very well-defined API, and then the JavaScript engine. And so what we do is actually have a little adapter for their API to be able to talk to our JavaScript engine, and everything else works the same. So in contrast to what was tried before with Nashorn, where they could never really run all of Node and the rest of the native parts of the JavaScript ecosystem, GraalVM runs any Node application or anything you can run with V8, you can run with GraalVM. And so that's a huge huge kind of victory in terms of compatibility with the JavaScript ecosystem, but bringing it all into the Java ecosystem and letting them work together. But not only can you run JavaScript in Node, you can actually run any of our languages in Node. So you can start invoking Ruby from Node or Java from Node or what have you. And that can be interesting for a number of use cases as well. So I think today the advantages of Graal's JavaScript, Java interop, obviously a huge benefit to use Java libraries or framework for JavaScript programs, adding in the value of the languages. JavaScript wasn't really designed to run with big heaps and efficient low latency garbage collectors. And so I think if you compare the garbage collector in V8 to a modern Java garbage collector and feed it a terabyte of heap, Node's going to die with a terabyte heap. And G1 or ZGC are going to be fine. And I think that's where you see a huge advantage to running JavaScript and running Node on GraalVM. Today, I think the disadvantage we have is we're still a little longer to start up a JavaScript program than V8, which was optimized for fast rendering of pages, and we're still taking a little more memory, and we have some more work to do to optimize the memory footprint for Node. But I think overall, as a Node engine, it's starting to become really compelling. I wanted to mention the GraalVM sandbox a little bit more. And what that basically is doing is the typical use cases where you want to have lots of little programs. You can think of it as a spreadsheet where the program might just be a formula in a cell. And you want to, or I want to have these little programs plug into some larger host program. And you want to provide a safe place, and you want to provide customization. So you can provide kind of your own operating system layer with our sandbox, and that's what we do in the database, but that's actually been useful for some embedded scenarios as well. And then you can restrict, what parts of the underlying host application are available to the sandbox, and whether or not the sandbox has access to creating threads, or we can restrict options, or you can force cancellation of the sandbox program as well. And we're starting to see more use cases where the Oracle customer wants to kind of be a hosting or a partnership service where everyone wants to have a marketplace now. And so if you want to be, let's say, you're a big internet broker and you want to allow small businesses to host a brokerage for their, maybe individual brokers to host a little customized site in the same way Amazon does for third parties. A lot more verticals want to do that. And so this is a great kind of infrastructure for anybody that's building kind of a common service, that's internet available, but that want to have customization that will involve code customization for many kind of bespoke businesses to run on top of that platform. And then coming in 20.3, we're really going to put in a lot more strict limits. Right now, those limits are kind of weak, and these are just options that go into the context where you can set the limits on those various things. I mentioned our tools. We have Visual VM is polyglot. Our first goal is to take all the existing tools and make them all polyglot. So here you can see a heap histogram with some R objects, some JavaScript objects, some Ruby objects here, all in the same stack, and how much memory all of them are using, which is cool. We have a lot of code that we're maintaining as part of Graal. This is just the open source version. So people sometimes just think about the compiler, or they think about ahead of time compilation. The whole language stack and our tools, make it's a pretty large source base. So we want to kind of encourage you guys to interact with us in the Graal community on GraalVM.org. Try out Graal Enterprise or Graal Community there. There's downloads. And submit things on GitHub. And then, importantly, follow us on Twitter. We do a lot of communication with the community on Twitter. So we're pretty active there. So please feel free to reply to our tweets, and we'll engage. So that's what I have to say today. So I'll take questions. Usually I spend more time at Java Users Group talks on questions than we do on the actual talk. So I think we can start with that now.
So yeah, thank you. I think I can see a couple of folks ask some questions on the chat, but would you like, for example, like Scott, would you like to directly ask your question to Eric?
The chat window, good.
Yeah, there's a chat window, but I'm just giving folks a chance if they want to ask you directly.
Okay.
Let me see. Let me kind of scroll back.
Yeah, we have. I have comparisons with JDK 12. I will go find some slides for that. It hasn't really made the garbage collector. Actually, the new garbage collector is big by default, and it kind of made things move. I think that some of my charts. I'll go back and look to my slides and find you the Java 12 ones. Let's see. I think some of those were Java 12 charts. That's 8. Some of these are older things, but I think this that's 8. All right, I'll go find some slides and present this 12 slides. It's not the thing that's actually happened with JDK 11 and plus is that G1 actually has slowed down peak performance a little bit because you're getting this lower latency. So you're guaranteed that a garbage collection pause doesn't take more than, you can set limits to it. I don't want garbage collection to take more than 10 milliseconds. And so that means there's more work being done at runtime. So if all you care about is throughput and peak performance, actually you want the parallel GC that's in JDK 8 by default. So that's why actually the best throughput numbers come from JDK 8. I don't want to obsess too much over performance numbers because there's so much variety based on your application. What we want to do is just motivate you to try it yourself. And on your applications, if you're just running the JIT mode, you can drop in another version of just download our JDK and see what happens on your app. Download Graal Enterprise definitely and play with it out and tweet about it. Let us know. Okay, so the next question I see here is JIT versus AO2 and the small talk messaging. So the thing that's very cool here, and there's an older version of my slides where I actually show calling Ruby methods that do an addition from a JavaScript function, and that whole thing compiles together like it was all written in C. Because what happens is we're inlining everything, and so the cross-language polyglot stuff, it just looks like another way to ask for get a field, and we watch to see what does get a field do. Oh, it adds an offset to a base pointer value. Oh, it's a 4-byte integer. It goes and grabs it. It watches what the interpreter actually did, and then compiles that in. And that's what partial evaluation does. It's a pretty complex area, but what's actually happening with Graal is we're taking an interpreter, and I have some more technical slides on another deck I can maybe go through, that that basically show what partial evaluation is doing, which is it's creating a compiler for you automatically from an interpreter. So if you write the truffle APIs where you say, here's a node, an operator node, and it's going to be a plus, and here's how I'm implementing plus for integer. It watches what that interpreter does, and then whatever that interpreter does, it follows that effectively, and then it compiles whatever that is. And then so if a JavaScript plus does something a little different than a Java plus, does something a little different than a Ruby plus, it just basically walks through what the interpreter did, what machine code had to be executed to run that thing, and all that gets inline together. So a cross-language call, like when you see something like polyglot.eval, right? Like if you ran, and I could maybe provide a benchmark for it, but polyglot.eval, this is the kind of the core of the multilingual interop. You basically give the name of the language, you give it a string to run. Like that string inlines just like it was written in the host language program. So I could put A plus B here and evaluate an R, and it'll run with the same performance as if it was in the host language program. It's really very cool. So there's really zero overhead there. Okay, how do you deal with the problem that AOT code is not fully Java? So yes, so there's a couple parts of Java that are not possible to implement in AOT mode. So like the way native image works, like by default, it actually will try to analyze your program, and if it can't figure out what we call the closed world assumption, which is that we know where all the classes and objects are at runtime at build time, then we actually fall back to run hotspot, so you can run everything. So when you run native image, it runs all Java programs. Now, what happens is, of course, the things that trigger us to go fallback, that aren't really directly supported by native image are things you often don't. You want to kind of not have that happen because you're looking for the performance or footprint benefits of AOT compilation. So I mean, there's basically two strategies. There's a few parts of Java that were kind of hard. We didn't think they were actually interesting to a typical kind of microservice type user that they turned out to be. And so on our roadmap for 20, we're adding in, I think, most of the remaining features that are implementable in the AOT context. So method handles, weak references, and Java serialization, which not recommended for new code, but a lot of code still uses serialization. That stuff will all be supported by 20.3. But there's going to be a couple features in Java that will never be supported by ahead of time compiled mode. And they're basically two key features. The one is most broadly just defining a class from an array of bytecodes at runtime. That's basically saying if your program says, I want to compile a class at runtime, and here's the bytecode, please give me back the class. That is something that won't work actually ever in AOT mode. And the other thing that there's some ways that Security Manager works, which is again kind of an out of favor now module in Java. That's something that we don't intend to deploy. So you may have seen a few weeks ago or a few months ago now the announcement by Mark Reinhold of Project Layton. And Project Layton is going to basically define a static version of Java that kind of explicitly says, hey, these features are not things you can count on. And that's basically going to be creating a class at runtime from bytecodes and the security manager, which allows you to do some weird things that, and I can't really kind of go into it, it's very complicated what security manager does that are kind of problematic for AOT. But because of other security vulnerabilities in the security manager itself, it's kind of not really a problem. So those are going to get spec'd out of a newer version of Java, and they'll be called static mode for Java. That's what Project Layton's about, is to kind of take in what GraalVM's done with ahead of time compiled mode, take out the parts that work really well, which is basically, like I said, everything except for runtime compilation, call that static mode Java, and that will be spec'd in. So that will be a new feature of standard Java. I mean, the Java standard changes, of course, as you know, every 6 months, and we deprecate some features and we add some features, and I think that the Java ecosystem is moving more broadly this way to support AOT compilation, because that's what you want to do if you want to be in the cloud. And so, I mean, really, the thing you have to be aware of is that a lot of the cloud actually has been using languages other than Java because specifically of the problems of runtime compilation, right? So a lot of the infrastructure of the cloud is built in Go. Even at Oracle, probably over 50% of the cloud is built in Go. And so I think that the Java language architects really want to make sure that there's no good reason to use Go. And so Project Layton and then Loom, I think together, they feel like will really be able to kind of address all those Go use cases. But in native image in particular, I think if you care about the cloud and that's where everyone's going, that's really the kinds of programs you want to run. So depending on a lot of dynamic activity happening in your program, not something you want to do if you want to build libraries that are going to be cloud friendly. So I think that's kind of where the Java ecosystem is going. If I run my Java program in AOT, may I use profiling, JMX, and other nice features of Java JIT? So we don't have support for all of them right now. As I said, JFR is kind of coming out, and I think there'll be a Red Hat version as well that'll go into Graal community. Some of those things are still kind of being finished for a couple different reasons. So the answer is yes, soon, but I don't think all of those things work right now. Yeah, there's a few issues with that right now, but I don't have exactly the details on it, but most of that monitoring stuff will be working by 20.3. You have charts of the languages used by the GraalVM stack and tools. In terms of chart, I guess the questions around compatibility, which tools support which languages. We basically try to make sure that all of our stack, if we say that the language is production, that every part of the stack works. So JavaScript's production, all of the stack supports JavaScript as well as Java, and JVM languages like Scala. I think Ruby is coming along really well, and so that we're going to make sure it's supported from all the languages in the stack. Right now, we really don't, I think, have too many kind of holes in the matrix where this language, on this platform doesn't work. I think it's pretty, uniform. There may be a few bugs, in some corner cases, but I think for the most part, the production languages work on all our platforms and work in all our tools. Does GraalVM support or plan to support low-level reflection ops like method handle? Yes, we'll be supporting method handle. I think that's coming either in 20.2 or 20.3. And reflection, as I said, is already supported. Will GraalVM be supporting Go in the future? People ask me, I'll just kind of generalize this to, what about other languages for Graal? Are we looking at other languages? The one that we hear about the most frequently is supporting C#. I would say that's the #1 request. The #2 request is COBOL. The #3 request is probably PHP. And then Go, maybe Go is above, in there kind of 2 or 3 as well. Yeah, COBOL, LOL. But there's actually a ton of, our unemployment systems. I think most states are running unemployment insurance on COBOL mainframes. It's amazing how people say, "Oh, great! Maybe this is a way I can kind of incrementally move off of COBOL onto the modern languages without having to rewrite everything from scratch." And the problem is, the fundamental problem with supporting a language is not the language itself; it's the libraries. And most libraries use a ton of native library. Most language libraries, like the Ruby library, the Python library, the C# library, the COBOL libraries, they use a ton of native code that is linked in directly. And sometimes the APIs of that stuff are well written, like in JavaScript, but sometimes they're not, like in Python and R. And so we spend a lot of time, and Ruby as well, to kind of make sure we are 100% semantic for semantic compatible with the interpreter for all the use cases the native code wants. And that's kind of grinding through all the native code is a challenge. If I can maybe go to our website. We have a compatibility chart that shows we download basically every npm package from npm every week, and we run all the tests that are there in Mocha, I think is the testing framework that they call it, and make sure they all pass, and that's how we get our compatibility ratings. And doing that for each language, it's all the library certifications that people really want. I mean, Java is not Java without the JDK. And JavaScript's not JavaScript without Node, for the most part. And so supporting all that stuff, that's the hard part. So that's why it is a little bit more of an undertaking. And we kind of are going to be a little more demand driven. I'd say that, by far right now the #1 language that we need to get production quality to make sure all the libraries work is Python. There's a rich Python ecosystem. We support SciPy and NumPy and a few of the basics, but it's still the case that you probably have a 50-50 shot of hitting a Python library that uses some native feature, that uses some weird, basically links directly into the Python interpreter, and wants some semantic there that we have some slight incompatibility with. So we're kind of banging through that. That's our big push now, I think, as far as languages. Get Python done. Get her done. And Ruby, we have a really good collaboration with Shopify. They put a lot of people on Truffle Ruby, kind of double this effective size of the Ruby team for Graal. And so those languages, I think, getting them production where you can use them and then just a drop-in replacement for everything, that's really our priority. The other thing that we do support that's really kind of interesting is you can run Go now in 2 ways. You can run Go. There's an LLVM front end for Go, and you can run Go on our LLVM interpreter, and that's the way we support native libraries typically. The other way you can run Go is that Go compiles to WebAssembly, and so we have a WebAssembly backend for GraalVM as well. That's becoming more of a kind of standard part of the JavaScript ecosystem. So those are 2 ways you can run Go. They aren't really designed, I think, for all possible Go use cases, but a number of them you can support that way. The languages we've chosen are the ones that we feel like the open source ecosystem is the most vibrant. If I go on the internet and say, hey, I want to search for a library that does X, Y, Z, how big are those libraries? How many contributors are there? Where do you see the most open source contributions going? Java, JavaScript, Python, and then like R and Ruby are definitely behind, but they have very vibrant open source ecosystems. A lot of the other languages like COBOL and C# tend to be more vendor driven, and there's not as much open source stuff out there around where we think that the polyglot value is much higher. And so that's why we focus on those languages. I'm not going to make promises on like the next language that we're going to support. But right now, Python is #1 goal is to get that done. And there are a lot of places where the Python ecosystem and the Java ecosystem can be complementary. I think most people do machine learning stuff in Python. The lack of a good set of machine learning library support for Java is kind of a constant pain point for anybody in the Java universe. And so you can run some things there now, but getting it to be certified, we're basically going to say we're going to support commercial customers. Any Python module you find with whatever native code in it, we'll run. That's our goal for Python, to go GA, and so we got a pretty large team that's focusing on that. And we actually do have a Smalltalk interpreter out there. There's a group at the TU Berlin, or not TU Berlin, University of Potsdam, and we've worked with them actually a lot. They have something called Truffle Squeak, and they do some really cool stuff with Smalltalk and Graal. That's not something we're directly supporting. There's other open source things out there. NVIDIA has a Truffle language for calling CUDA from in the middle of Graal apps. I think that's an interesting use case for some things, etc. So that's what's going on there. Okay, so what languages GraalVM is created in? GraalVM is written in Java. So Hotspot's written in 100% in C++. So we're big believers in eating our own dog food. So one of the reasons we think that the Graal team is super productive is we're writing a VM in Java, and we can refactor things, we can add new features much more productively in Java than in C++. That's probably why you guys are all in the Java users group and not the C++ users group, right? So you probably believe in that. We believe in it too, and it's been a dream for a long time to have Java written in Java. And that was actually one of the most important original motivations for the research project that started in Sun Labs called Maxine, that turned into what became the Graal research project in 2010 and 2011 after Oracle acquired Sun. The Java VM in Java was a big deal. And so that's actually, if you actually start playing with the internals of Graal, one of the coolest things about it, I think. And really, I think over the long term, the productivity of us being able to add more features, more languages, more optimizations on the Graal source base is going to be much higher than continuing to grind along with the C++ code base that's there in Hotspot. It's now about 20 years old. So will GraalVM reduce the amount of copying involved in talking to C libraries from Java? Absolutely. That was a huge thing that we did for Substrate VM. So in Substrate VM, there's a kind of a much more direct mode. Basically, there's zero overhead to call C libraries from Java in native image. That is one of the biggest reasons that that we like to use native image. We use Java code in native image pretty much interchangeably with places where you'd want to use C code. It compiles into a binary. It links in with, basically you can use all of your native tools. You can use GDB, you can use vTune. It really looks to like all the tools like a native C program. It's just you have long function names that have like Java packages in them. So if you ever play with native image in the C library, we have a different alternative version of JNI that you can use in native image. We've done that. That's what we do internally. And one of the biggest projects we completed this spring, maybe last year, was called libgraal. And what libgraal is libgraal is Graal compiler, which is Java, compiled with AOT into native code, and then you link it into Hotspot. So one of the weak points of Graal, like last year, was that you had to warm up Graal because Graal itself was Java, so you had to JIT compile Graal itself, and so that meant our warm-up performance was worse. And so now Graal is ahead of time compiled into native code, linked into the C++ runtime in the Hotspot VM, and then the compiler itself starts up fast. So people don't actually realize this, but now the default garbage collector in Substrate VM is a very simple, lightweight stop and copy collector. It's not really meant for like a lot of heavy allocation, deallocation use, but it's fine for a compiler. And we throw away basically the whole heap whenever the compilation is done. So I don't really care about doing garbage collection with this thing. But that little garbage collector is actually running in Hotspot just to be the garbage collector for Graal. So the Graal compiler in Hotspot is using Substrate VM's garbage collector. So you think you need to be running G1 for your application, and it's still running our little stop and copy collector for libgraal, which is that specific native library linked into Hotspot. That was actually a big project that we completed, in the last year. That's been a huge milestone. Okay. Can the AOT target other architectures like ARM32? Yes. So we have we targeted our ARM64. ARM64 is available in our community edition. We're waiting for the official Oracle JDK to support ARM64, and that's slated for end of the year. And so then we'll be production on ARM64. And Oracle's definitely doing a lot of investment for ARM64. Now, the other thing we have that's really ultra cool is we have, I mentioned an LLVM front end. So you can take LLVM programs, compile them to LLVM bitcode. We interpret that bitcode, and that's how we support C, C++, Fortran, Rust, all of the static languages that are compiled typically with LLVM. We can take their output and run it into Graal. Now, we also have the LLVM as a backend. So you can take Graal and you can feed it. It can generate, rather than machine code, it can generate LLVM bitcode, and you can use LLVM's backend compiler to do like the low-level machine type of optimizations. And so that's the supported way. I wouldn't say officially commercially supported, but that's the way that works now. It's kind of an experimental thing to support other architectures. So if you want to run on MIPS, on RISC-V, kind of non-traditional processor architectures, because most of the processor vendors have put in a backend for LLVM, you can use that backend to generate machine code with Graal on those architectures. So if you want to run Java on RISC-V or Java or JavaScript on MIPS, right? That's the way you can do it. We've done a bunch of simple examples and use cases for it. We're actually maintaining the ARM32 target as a backend for the LLVM backend that we actually test to make sure it doesn't bit rot. And that's what we call it, the reference version of the compiler for ARM32. Now, the LLVM backend is not as efficient as the Graal backend, and I'd say you're going to lose 10 or 20% performance if you're generating machine code with the LLVM backend rather than the native Graal backend. But the native Graal backend, we have to explicitly tune it for every processor architecture, and right now that's just x86 and ARM64. We are putting in a lot of effort into ARM64. Oracle actually has a significant investment in an ARM server company called Ampere, and so I think we've announced that we're rolling out some Ampere ARM64 servers in our cloud, and so the whole Oracle product stack has to work on ARM64. So that's going to be something that you'll see more of at Oracle. If I understand your definition of how polyglot.eval works, it will reproduce the quirkiness of JavaScript. Yes, you can. It's going to call the Java. The way polyglot interop works is there are messages that polyglot interop supports, like get field, invoke method, ask for array element, and so forth. And those messages have to be supported by each of the language runtimes. And there's kind of a default support for that is provided by the interpreter by the Truffle APIs. But yeah, you can make array indexing in Java do weird stuff if it's not operating on a Java object. Array indexing on a JavaScript object could be whatever implementation you want, right? A plus B is going to, if you eval A plus B in Java, and but and specify JavaScript as a language, it'll use JavaScript semantics to execute the A and the plus and the B, and return the result that JavaScript had as an object into Java. And I'm not the right person to talk about all the quirkiness of JavaScript, but you can make sure that your Java code does everything, all the weird crap from JavaScript, by polyglot.evaling your way into whatever. You can make an arbitrarily large program there and have it do that. The place where things I think get a little bit more surprising sometimes is when you just pass back a JavaScript object to a Java program and ask it to treat it like a Java object, and that all works. But there are places where I think there's some corner cases that seem a little bit weird, and so for each pairwise set of languages, we often have to kind of do a little bit of polishing, I'd say, to kind of handle some of those corner case scenarios that when you're basically I'm running Java code, but with a bunch of objects that were created by Ruby. Sometimes you're getting Ruby memory layouts and Ruby and implementations of get field and set field. And there are places where that leaks through the Truffle polyglot interop abstraction. Okay, yay, he's answering. Let me take a pause for a second and just get a little water here or something to drink. One more is about pointer optimization, aka dense memory. Can Graal optimize the pointer to keep the data close, i.e. relative pointers or something? So in Substrate VM, we have a lot more tools. So we support compressed loops in Substrate VM. We have a lot more capacity to do cool tricks like inlining and so forth. You'll start seeing more of those kind of things happening in the next year or two. And those are just ways that, we can start to use all the cool tools that Graal's giving us to get more performance benefits. And yes, you can do the way, so because Substrate VM actually supports a construct called an isolate. And what an isolate is it's a Java heap, but you can have multiple ones. Now, isolates are what they say, which is that they are isolated, like the Java objects in one isolate by definition cannot point to objects in another isolate. So you need to use keys like strings or something to go basically talk between isolates. But isolates have basically they have relative pointer addressing. So if you say your isolate is small, I only want, let's say, a megabyte in this heap, that gives you compressed pointers, and that they're all relative to the base address of the isolate. We're not yet optimizing enough to get 24-bit pointers in small isolates yet, but that's a fairly straightforward extension we could do at some point. I think once you get below 32 bits, the benefits are not as clear, but It's not the low-hanging fruit optimization, I would say, but it's definitely something that's very viable. Will something like Apache Spark run on Graal? Yes. There's a really cool blog post we have recently out there. And maybe I'll stop sharing this. But if you go onto Medium, I'm just going to bring up a web browser here and start searching for stuff for people. And there's a cool blog post on Apache Spark and Graal. And let me share the browser. Share. Okay. Can do it? Yes. Okay, so here I have my new browser, and I'm just going to look for GraalVM Apache Spark. And this is it. All right, you have a blog post, and this is not what we want. This is not what we want. This is our blogs page. WebEx is making this slow. This is it. Apache Spark, lightning fast on GraalVM Enterprise. Okay, so here's the blog post. It's on Medium. And what we did is we did some benchmarking of Apache Spark on GraalVM, and you can see kind of the benefits there. Here we have some OpenJDK and OpenJDK 11 numbers, so you can kind of see, you know, what the benefits are. Your mileage will vary, of course, you know, depending on the benchmarks, but we have some good numbers on Apache Spark, showing memory footprint things and so forth. So definitely check out that blog post. GraalVM lightning fast on Apache Spark lightning fast on GraalVM. So so look for that. How do I get back to the chat window? We are going to, one of the things that's coolest about Apache Spark and Graal is PySpark. So a lot of people run Python, you know, for machine learning in Spark. And the way that's done today is there's a Python, you know, interpreter that's running in a separate process, and there's IPC basically to pass data back and forth between the JVM and the Python interpreter. So being able to run them both in the same runtime is super cool. We have some very good numbers on that right now, but you know, it's not super interesting until, of course, we can support basically all the ML libraries that are out there, you know, practically. So Apache Spark is definitely something we want to tune the crap out of. We've done a bunch of work so far. I think you'll see more from 20.3 in particular for Apache Spark. One of our goals that we've been doing in the past year is to start picking off, like, I think the most popular pieces of Java middleware, Apache Spark, Elastic, and Kafka. Right now we're doing a big push on Kafka. Tuning Graal Enterprise for Kafka, showing benchmarks there, getting runtimes there. So we're gonna, that's kind of what you're gonna see as like a next role. And then of course WebLogic, we did a big push to make WebLogic faster on GraalVM, and we got some numbers there showing up to 30% faster on WebLogic. And so that you know, so that's kind of like the next step for us, I think. And that's what'll happen there. Is that GraalVM sandbox thing safer than, say, using Lua? I can't really comment on Lua. You know, the sandboxes are, you know, are just a place that you can isolate part of a program and put controls over the part of the program. And you can say, I don't want that program to use up too much memory, that little subprogram to use up too much CPU. So you can put limits on it so that it can't go wild on a number of dimensions, like, you know, create a denial of service attack. That's kind of the use case for the sandbox. Sandbox is a very overloaded term, and you know, I think the short answer is it depends. Lua, you know, it's not any safer than any other JVM language, you know, I guess inherently, in that it's just it's another managed language. You know, you can't scribble over random memory. But I think a lot of controls in the sandbox that are pretty compelling. And yeah, the first time I've heard that question, but thanks. Let's see, any other questions? Has GraalVM been used to speed up Maven, Gradle, or Java-C? Yes, actually, we have we do have a little prototype of a fast Java-C so that it compiles faster. Actually, the big win is on Scala-C. If any of you are Scala programmers, Scala-C is known to be pretty slow. So that's been huge for us. We haven't really kind of made a lot of hay out of it. We haven't tried to like make it as part of our download. We did some bench. I think there's a blog post out there with some experiment on it, and some people have run it. It's a cool thing. We may at some point decide to like bring it into the fold of things that we're trying to support. But let us know. I mean, that's kind of one of those things. If you go to our GitHub page, and I'll just do that now. GitHub.com/Oracle, and then Graal is always on top. And go here, and we have lots of people commenting. 665. This is open issues, but file an issue here, right? We've closed 1,230. We've only been kind of for real for like maybe a year and a half or so. So maybe it's up to 2 years now. Please post something here if you have a use case for us or something you think's interesting. Definitely post an issue on GitHub. We'll try to get to it, and we're pretty active there. It's well staffed, and you can kind of see a lot of interplay there, and again, of course, on Twitter. Any more questions, like verbally? It's my first virtual jug.
Oh, really? Yeah.
Cool. I did Portland and Seattle jugs in February, and that was in person. I flew up there.
Oh, I see.
So it's kind of weird. It's like it's a monologue. I can't really read the audience and see are people like excited or like bored or what have you. So yes, you have to bring your own beer and food.
Yeah. And we are actually going to have our virtual drinks if you want to hang around, but you have to bring your own drinks. So yeah.
I will do that. I got some Corona beer in honor of the virus. So I'll drink some of that.
That's cool. Yeah, so let's see. Do we have? I copy over your URL for your Graal issues. So just so folks know on this chat. And let's.
If you want to send me an email, I'll send you the slides.
Oh, okay. Yes. Yeah. I'll send you an email and then I will post to our meetup.com page for that link. So yeah. And let's see. Do we have more? I think Matt has one more question.
Matt has a question here. Does this enable native coding from Java? Yes. Like we use Java to write native programs, and that's actually a really good use case for ahead-of-time compilation because they work just like native programs, right? I mean, the linkages, you see them in GDB. You can like optimize them with vTune. There is this little garbage collector thing on the side, so it's not exactly the same as native code, but the code works like native code, and you can pass objects back and forth, and it's a much it's different than JNI, right? It's using Java as the language to generate native code, and that's another way you can think of native image. All right. Cool.
All right.
I guess I'll get up for a second and get some beer.
Sure. Yes. So thank you again, Eric. Yes.